So let's go ahead and get started with this first one. We're going to start off with question number 1, relative extrema. I'm going to give you the first derivative. I give you the first derivative, f prime of x equals quantity x minus 4 squared times x squared minus 1. And what I want to do is I want to find the relative extrema. Okay, great. And by the way, I encourage you, whatever I write down, I encourage you to write down as well, by the way. If you're just watching this, I think you're an idiot and a loser, and I hope you fail. So please write everything down. Okay, so f prime of x equals x minus 4 squared times x squared minus 1. How do we find relative extrema? What we're going to do is we're going to set the first derivative equal to 0. Now, since I gave you the first derivative, you're setting this equal to 0. Do not take the derivative of this, because that would be the second derivative. And what do we use the second derivative for? Only for concavity and points of inflection, which is not what this question's about. First derivative is how we find maximums and minimums, extrema. So in order to solve for x, some of you, there's two camps of people out there. Some of you are going to want to FOIL out the x minus 4 and then combine all the terms. If you do that, you're really shooting yourself in the foot, because this is the form we want it to be in. We want it to be in the factored form, because I'm going to set both of these terms equal to 0. That's how we solve. So it's going to be quantity x minus 4 squared equals 0 and x squared minus 1 equals 0. For the left side, a lot of people get tripped up by this, but it's not that bad. You just take the square root of both sides. It's easy. And then x minus 4 will just equal 0. So x equals 4 is one of our solutions, our critical points. Then for the other side, x squared minus 1 equals 0. You can add 1 to both sides. X squared equals 1. And x is just going to equal square root of 1 plus or minus. So plus or minus 1. These are our critical points. We have 3 critical points. Now that's not the answer to our question just yet. Remember, now we're going to do the first derivative test, which involves plotting these points on a number line. -1, +1, and +4. And then we just need to plug in points around these numbers and see where it switches from positive to negative slope or negative to positive. So I need to plug in a point less than -1. I can choose any point. Let's choose -2. And I'm plugging into the first derivative, which is this function right here. So I plug in -2. I'm going to get -2 minus 4 squared times -2 squared, that quantity squared, minus 1. Okay, now here's the nice thing about this factored form. I don't care about the actual number. I just care if it's positive or negative. So for instance, -2 minus 4, that's -6, right? And then -6 squared is actually going to become positive 36 now. So I don't care about the 36. I just care that it's positive for this factor. Then for the other one, -2 squared becomes +4. +4 minus 1 is +3. That region is going to be positive when x is less than -1. Now I need to pick a number between -1 and +1. I'm going to choose 0. So that would be 0 minus 4 squared times 0 squared minus 1. 0 minus 4 squared, that's -4 squared, which is +16. So positive there. 0 squared minus 1 is going to be 0 minus 1, so negative. So we see negative for that region. Now let's just keep plugging in. It's just like this. I plug in x equals 2 next for the middle region there. 2 minus 4 squared times 2 squared minus 1. That's going to be -2 squared, which is still positive. 2 squared minus 1 will also be positive, so that region's positive. And then the last one, a number greater than 4, I can choose 5. So 5 minus 4 squared times 5 squared minus 1. Again, this is going to be positive everywhere for this one. So positive there. Now we're very close to finding the answer. There's just one last thing we need to do left, and that is consider the sign changes. Like for instance, at -1, we see we're having positive slopes followed by negative slopes. In other words, increasing followed by decreasing. I know there's a max at x equals -1. Then at +1, I see negative slopes followed by positive slopes. That's going to be decreasing, then increasing, which is a minimum. Great. And then at 4, we have positive and positive. Since there's no sign change, that's going to be neither. That's going to be neither. So my final answer, I can say max at x equals -1 and min at x equals +1. Okay. That's it for the first one. Any questions? Anyone still writing? Now, I do want to continue with this problem, actually, because one thing that I think you guys are terrible at, and it's not your fault, but it's definitely not my fault yet, and that is you guys don't know how to draw functions, I would say, for the most part. Like, for instance, if I gave you this derivative, and we just found this number line, and we found the positive and negative slopes, a lot of you guys stink at drawing these graphs, what it looks like. So I'm going to tell you there's a part B to this question. Let's say part B. I'm also going to give you some values of the function. I'm going to say the value of 4 is positive 5. The value at 1 is negative 2. And let's say the value at negative 1 is positive 3. And I want to draw this graph. Okay, so the first thing I'm going to do, I'm going to make a big number line here. Really, just a set of axes. I have negative 1, and positive 4 somewhere down here. Here's x. Here's f of x. Okay. Now first I'm going to plot these 3 points. I know at 4 the y value is 5. I don't care what exactly it is as long as it's close. It looks something like this. At positive 1 the y value is negative 2, so something down here. And then at negative 1 the y value is positive 3, so something like that. So as long as it's something close, I don't care. This is perfect. Now remember what we said. Look back at our number line here. So the number line said around negative 1 we have increasing slopes followed by decreasing slopes, and it's a maximum at negative 1. What does that look like on this graph? Well, positive slopes, then maximum, then decreasing slopes, just like that. Now what's going on around 1? What's going on around 1? Looking back at the number line, I see negative slopes followed by positive slopes, and there's a minimum there. So I'm just going to kind of connect the dots, going down, hits that point, then starts going up again. Now here's the part where most of you are going to mess up. At 4, what's going on at 4? If you say, oh, well, it hits 4 and then keeps increasing like this, like how I just drew, don't actually draw it like this because this is wrong. But if you say this because, oh, you see positive and then positive slopes, so how is that wrong, Dan? I'm glad you asked. It's because what's the slope at 4? Remember, what was 4? It was a critical point, right? What's so special about critical points? Well, first, it's where the max and the min occur, but another definition of a critical point, it's where the slope is 0. So the slope has to be 0 at 4, but it's increasing everywhere else. So increasing, 0, increasing to infinity. And this is what the function's going to look like. Something like this. Very fun problem. We're going to do another one just like this. So if this didn't make sense, don't worry. We're doing another one. Any questions, though, in this first one? Great. Anyone still writing? Awesome. So for the next one, it's the same thing, except I wanted to throw another mix into the bag of tricks. I have f prime of x, the first derivative again, equals quantity x minus 3 squared divided by x. So again, we want to find first the relative extrema. Let's find the relative extrema. And to do that, the first thing I'm going to do is set it equal to 0. Now, since I have a fraction here, you need to remember whenever you have a fraction in your first derivative, you set both the numerator and the denominator equal to 0. So with the numerator, you have quantity x minus 3 squared equals 0. To solve for x there, you just need to take the square root of both sides, as we did before. You're going to get x minus 3 equals 0, so x equals 3. That's one of our critical points. The other one's easy. It's literally just x equals 0 from the denominator. Okay, now let's talk about these critical points because they do mean different things. So since x equals 3 was in the numerator, it means that the slope is flat at x equals 3. Since it's in the numerator, the slope is flat at x equals 3. Since x equals 0 is in the denominator, it means that the slope is not flat, it's the opposite. The slope is vertical. It's actually going to end up being a vertical asymptote in this case, which happens a lot. Okay, so now we're still going to make the number line. Everything else stays the same with this problem as the last one. I put on 0, I put on 3, and now I just need to plug in points around these in these 3 regions. So let's start with negative 1. I'm plugging negative 1 into x minus 3 squared over x. So negative 1 minus 3 squared over negative 1. I see that negative 4 squared is going to be positive 16, so positive in the numerator. still negative in the denominator. That whole thing's going to be negative in that region. Okay, then I plug in a point like positive 1 here. So positive 1 minus 3 squared over negative, positive 1 now. So notice that's going to be negative 2 squared in the numerator, so positive 4, divided by now a positive in the denominator. We get a positive there. And then I just need to plug in a point greater than 3, like positive 4. I get 4 minus 3, quantity squared, over positive 4. It's going to be positive over positive again. So positive in that region. And now if I were to ask us, where's the maximum, where's the minimum? We see at x equals 0, since we have negative followed by positive, that's going to be our minimum, right? Minimum at x equals 0. And then at x equals 3, again, it's neither because there's no sign change. So I'm going to say min at x equals 0. Now, one more thing I want to say about this. When do you have to give the y value, or the value f of x? Like in this case, I only needed to say the x value, right? When do I need to give the y value to? The answer to that question is for absolute extrema. So if you want to write this down, I encourage you to. Only give the y value for absolute extrema problems. Since this was relative, we didn't have to do it. Okay, I'll give you a second to write that down. And then you know what's coming next. We're going to be drawing this. Okay.
If it's absolute,
yes.
Do we do the same steps to find the maximum?
That's a good question. I'll answer that in 1 minute, okay? Okay. So part B for this question, I want to draw it. And let's say this time I'm going to give you the values f of 3 equals positive 1. And I'm also going to say at x equals 1, there is a vertical, I meant 0. At x equals 0, there is a vertical asymptote, which I call VA, but it's really a vertical asymptote. If you like abbreviations, I would call it VA, but not everyone does. Okay, so how would we draw this? So again, first, I'm going to draw my axes. I've got x, I've got f of x. And at 0 I have a vertical asymptote, which I'll draw with this red dashed line here. I'm assuming you don't have colored pens, but that's okay. And then at x equals 3, we know the y value is 1. So now I need to draw this, okay? Now, I don't know what's going on at any other points, but I do know this. Looking back at my number line, it's negative slopes before 0. So it's negative slopes. I'm going to draw this. Well, where does it go to if it's just negative? Since it's an asymptote, it's going to negative infinity. It's going to negative infinity, like that. And then on the other side, it's increasing from 0 because of the positive slope right there. So if it's increasing, then it's going up, 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 up. And then when it hits 3, even though 3 is not a max or a minimum, 3 is a critical point, right? And since it's a critical point, it's going to have a flat slope. And then looking back at the number line, it's increasing again after 3. So it's going to finish out like that. And this is what our graph is going to look like. Something like this. Any questions?
How do we know if there's a horizontal asymptote?
That's a good question. We're going to talk about that in a later question, but I'll tell you this. What did I give you? The first derivative? You cannot answer that question from the first derivative. You need to do it with the original function. But that's a good question. Okay? Great. Now to answer the other question, what's the difference between relative extrema and absolute extrema? So let's just say, and you can write this down too. Let's say I want to, the function was f prime of x equals, what was it? X minus 3 squared over x. And let's say I want to find absolute extrema on, let's say, -1 to, well, that's not a good example, +1 to +5, let's say. I don't want to include -1 because then I'm including negative infinity, which gets kind of weird with absolute extrema. So I'm just going to tell you, you're not going to see that on the test, I promise. So with absolute extrema, the difference is, first of all, you're given bounds. However, half of the problem is the same. What do I mean by that? For absolute extrema, you still want to find the critical points. You're still saying the numerator and denominator equal to 0. You're still going to get x equals 3 and x equals 0. The The thing that's different is you don't make a number line. Instead, you're going to plug this point, your critical points, and the bounds, x equals 1 and x equals 5. You're going to plug all 4 of these points into your original function, which obviously I didn't give you, so we can't finish out this example, but that's what you would do. Now, there's one last thing I need to say, and that is one of our critical points is out of bounds. What do I mean by that? Well, my bounds were from 1 to 5, and 0 is outside of my bounds. So what do I do with that? I ignore it. So really, I only need to plug in 3 points into the original function. I'd plug in f of 1, I'd plug in f of 3, and I'd plug in f of 5, and whichever one's the highest, that's the absolute maximum. Whichever one's the lowest, that's the absolute minimum. And remember, you need to give the x value and the y value for these types of problems. Any questions on this one? I'm going to give you a minute to write that because I said a lot.
So you said the highest would be the maximum and the lowest is the minimum?
Yes, that's correct. If you have a tie,
Okay.
then they're both the maximum or both the minimum. Okay, I'll
Do you
give
plug them back into the first derivative? Or
No,
at the
original
back?
equation. Original equation for absolute extrema. Any other questions? I think you're likely to see 1 absolute extrema and probably 2 or 3 relative extrema, honestly. Relative is more common. Okay, with that, we're going to move on to the next question. Anyone still writing? Great. So for question number 3, believe it or not, we're only on number 3. It's going to be a long night, but I'm going to try and keep it entertaining, light, and fluffy, like an Eggo waffle throughout the night. So number 3, we want to find horizontal asymptote and vertical asymptote. Again, I like abbreviations, so I'm going to say ha and va, horizontal and vertical asymptotes. And the function is g of x equals x plus 5 divided by x squared minus 2x minus 8. So let's go ahead and find the asymptotes here. First, just take like 10 seconds. I want you to think about how you find horizontal and vertical asymptotes, and then I'm going to answer it. Okay, that's plenty of time for you to at least get your heads thinking. So we're going to start with vertical asymptotes because those are easier. So for vertical asymptotes, all you need to do is set the denominator equal to 0. Set the denominator equal to 0. Now, luckily, this is factorable. I'm just going to tell you, on your exam, the questions should all be factorable. I can't imagine you need quadratic formula for a vertical asymptote. That'd be unnecessary, in my opinion. So it's quantity x minus 4 times quantity x plus 2 equals 0. We're going to get x equals 4 and negative 2. Those are our vertical asymptotes, VA. Great. Then for horizontal asymptotes, these are harder. Do not set the numerator equal to 0. That's not what a horizontal asymptote is. A horizontal asymptote, this is our rules of limit at infinity, if you remember from before. Limit as x approaches infinity of x plus 5 over x squared minus 2x minus 8. Now remember, there's 3 rules. This is the case where the degree of the denominator is bigger than the degree of the numerator. So denominator greater than numerator for the degree, because it's squared, which means the answer is always going to be 0. Y equals 0. That's a horizontal asymptote. Vertical asymptotes are always x equals. Horizontal is always y equals. And since the denominator was bigger, it's always going to be 0. And don't worry, we're going to be talking about the other 2 cases right now. But first, anyone still writing? Okay. So that's it for number 3. Number 4, exact same question. Find horizontal asymptote and vertical asymptote. For this function, I have h of x equals 2x squared minus 4x plus 11 divided by, in the denominator, I have x minus 3 times x plus 4. So again, we're going to start off with vertical asymptotes because those are always easier. Now this one, I was especially nice to you because it's already in factored form. X minus 3 times x plus 4 equals 0. This is super easy. X is going to equal 3 and negative 4. There are our vertical asymptotes. Any questions on that? Now for horizontal asymptotes, again, it's harder, especially because this time I don't know which degree is higher just yet. Don't say the numerator because we need to FOIL this out in the denominator. So when I FOIL it out, I have 2x squared minus 4x plus 11 in the numerator. In the denominator, I'm going to have x squared minus 3x plus 4x minus 12. But luckily, I only care about the leading degree, x squared in the denominator and 2x squared in the numerator. Now, since these degrees are equal, hopefully you guys remember this, it's the ratio of the coefficients. What does that mean? We're looking at the 2 in the numerator, and really it's like an invisible 1 in the denominator. So the answer is y equals 2 over 1, or just y equals 2. That is our horizontal asymptote. Any questions on that one? And then I didn't have an example for the other one because I think you get the point right now. But if you have, I'm just going to make a note of it. Note, if numerator is greater than denominator, then there, and that would be an example like x cubed over x minus 1, for instance. Numerator's higher than denominator. In this case, there's no horizontal asymptote because this limit does not exist. No ha. Any questions? Okay. Anyone still writing? So now we're going to continue on with the next topic, still within the same vein of extrema and critical points and all this stuff. It's going to be the following. I need you guys to write all of this down. It's annoying. I know. I apologize. We're going to find the relative extrema. And now here are the points I'm going to give you. F prime of 2 equals 0. F prime of negative 2 equals positive 7. And f prime of 6 equals 0 as well. I'm also going to give you the following values for the second derivative. F double prime of x is less than 0 for x is less than negative 1. F double prime of x is greater than 0 for negative 1 less than x less than 5. And then f double prime of x is going to be less than 0 for x is greater than 5. I'm going to give you like 10 seconds to write this down. But for those of you who are finished writing, I want you to think about what kind of question is this? What kind of question is this? And the answer is that it's going to be a second derivative test question. So what does that mean? Well, how do we use the second derivative test? Because that's actually something that most people aren't super familiar with, because first derivative test is way easier. Again, first derivative test, you find the critical points, you set the first derivative equal to 0, you plot the number line, then you plug in all the points, yada, yada, yada. We like that. We don't like the second derivative test, mostly because it's confusing and we don't use it that often, so we forget it, which is fine. That's what I do too. Well, if I could forget anything. Now, with the second derivative test here, what I'm going to say is, for second derivative test, the process starts out the same. In other words, you want to actually set the first derivative equal to 0. You want to find the critical points. Find critical points. That's the first thing we do. So like for this problem, where does the first derivative equal 0? I give you 3 points, f prime of 2, f prime of negative 2, and f prime of 6. It's f prime of 2 and 6 that we care about. In other words, x equals 2 and 6 are our critical points. So that's good. Now here's the thing about the second derivative test and the thing that everyone gets wrong. Most people will say, oh, you take the second derivative and then you set it equal to 0. This is wrong. Do not do this, because second derivative, remember, is concavity. If you set equal to 0, you're finding the points of inflection, not the max and min. If you want to find the max and min, you need to use the critical points, because that's why they're called critical points. It's where the relative extrema occur. It's where the max and min occur. So then why is it called the second derivative test? It's because we take the second derivative and we plug in the critical points into the second derivative. What do I mean by that? Good question. So if I take f double prime of 2, for instance, f double prime of 2, then I'm going to say, I'm going to scroll up just for a second, and I say to myself, x equals 2. Which region is that in? Don't look at these. Don't look at these values I just underlined, because this is the y values. I'm talking about the x values. X equals 2 is this region right here between 1 and 5. So I'm going to be saying the second derivative is positive. F double prime of 2 is positive. And at the end of the day, I only care if it's positive or negative. If it's positive, then it's going to be a max or a min, right? Now, before I answer that question, remember, positive does not mean max automatically. It means concave up. And concave up looks like a minimum. And that's because it is a minimum. So it's the opposite of what you'd expect. Min at x equals 2. This is the first answer to our question. And then f double prime of 6. For this one, I'm going to scroll up again just for a second. So x equals 6. Notice that's going to be in my region when x is greater than 5, right? 6 is greater than 5, which means I then look at this portion right here. So that's less than 0, so negative. F double prime of 6 is negative. Negative means concave down, means frowny face, and it also means max. So max at x equals 6. Anyone have any questions for this one? Now there's one more thing I do want to say. I'm going to scroll up just for a second. What was going on at -2, right? I gave you the point -2. F prime of -2 equals 7. What did that mean? It meant that, well, first of all, the slope wasn't 0. F prime of -2 is not 0. I don't care about it for relative extrema. But something is going on there. Since it's 7, 7's a positive number. It means the function's increasing at -2. At +2 and +6 are critical points. That slope's flat. But at -2, that slope is positive, a +7. Okay? Any questions on that one? Anyone still writing? Okay, great. Let's continue moving on to number 6. So that's going to wrap it up for Extrema. Of course, I encourage you to do more problems on your own, but we need to move on to bigger and better things. We're at 6:30 right now, which is exact, like to the minute of where I want to be right now. So this is a good sign so far. Bad news though, kids, because we're going to be talking about optimization, and I know how much some of you hate optimization. It's funny. I loved optimization in calculus back in high school when I took this class, because it was one of the few things that was actually like a real world application of calculus. The problem is these problems are really, really difficult. Especially the one that a lot of you guys got on the quiz last Friday, which was the box folded up on the sides. And a lot of you complained because you didn't know how to do that one. That's why we're going to be talking about it right now. I don't know if it's going to show up on the exam or not, but I'm going to tell you one thing. I want to talk about it, because if it does, I don't want you guys to be screwed over. Now, the one thing about the box folded up example, well, first I should give the dimensions. This is a 12-inch by 12-inch box, let's say. It's a complete square. And on the sides, I'm cutting off x on each side. I'm cutting off x. So if any of you have met with me before, we've talked about optimization. We've said that optimization, you have the objective and you have the constraint equation, and you're trying to maximize something or minimize something. So let's say in this case, I want to find what is the max volume of the box. That's my question. What is the max volume of the box? And typically we have our objective equation, which the objective would be what we're trying to maximize, in this case volume, and the constraint would be the other number we're given. So I'm going to tell you the hardest part about this problem is there's no constraint equation. I repeat, there's no constraint equation. There's only an objective. I'll talk about why in a second. But first, let's talk about the objective equation, because this is hard enough on its own. First, I can't be using this box that's not folded up yet, because our box at the end of the day is going to be folded up. It's going to look something like this, like a rectangular prism with an open top. So now if I ask myself, what's the volume? Well, length, width, height. Volume of a rectangular prism is length times width times height. I recommend you know that. Now here's the thing. The length is not 12. The width is not 12. Even though that's what most of you would be thinking right now. And that's because it's not 12 because we just folded up the sides, right? We folded up the sides of distance x on both sides. In other words, this right here, I'll draw it in blue, is really the length of my box. Notice it's 12 minus 2x. And the same thing's going to be true for the width. The width is also going to be 12 minus 2x because you're folding up the sides. So the length is 12 minus 2x. The width is 12 minus 2x. What's the height? The height's actually just going to be x because that's how much you're folding it up. So let's write it out. Volume equals length 12 minus 2x times width 12 minus 2x times a height of x. This is my objective equation. And now, if I were to ask myself what's the constraint equation, I'd kind of be at a loss here. There's nothing else to take an equation of. And why do we have the constraint equation in the first place? If you have no idea what I'm talking about with the constraint equation, I apologize, but we'll deal with another problem next that does have a constraint equation. But normally the constraint equation, we have x and y, right? We have x and a y in our problem. However, notice I only have x here. And the reason we had the constraint equation was specifically to solve for one of our variables and then plug it into the objective. But if I just have one variable, x, I don't even need a constraint equation. And in case you're wondering, does this happen often? Does this happen often? This is the only problem where that happens. Literally, like I've seen 100 problems in this class. This is the only one where that happens. And they threw it on your quiz, and I am so mad that they did that because we did not talk about it. So now we're going to find the maximum. To do that, we need to take the derivative. But first, of course, it would be a lot easier if we factored this first. So volume equals 144. I'm going to FOIL this. Minus 24x minus another 24x and then plus 4x squared. This whole thing is then multiplied by x. I now need to distribute x to every term. So I'm going to get volume equals, I'm going to do two steps at once here. I'm going to multiply by x, and I'm going to rewrite it from highest order to lowest order. In other words, I'm going to say it's 4x cubed minus 24x and 24x combined to be negative 48x. So that's going to become negative 48x squared now. And then plus 144x. I kind of just, I did the algebra. I'm sure you guys could do that on your own too. But any questions so far? Okay, great. Now the next part, we're going to take the derivative and set equal to 0 to find the critical points, because that's how we find maximums. The derivative of this is 12x squared minus 96x plus 144. And then we're going to set this equal to 0 and solve for x. Now, here's the thing. On the quiz, you had to use quadratic formula. And if you were to use quadratic formula, how would you use it? Remember, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In case if you're wondering, do you need to know this for the exam tomorrow? Honestly, I don't know. It could show up. It might not. I hope it doesn't show up, but I also hope if it shows up that you know how to do it. In other words, my recommendation, have it memorized. You should have had it memorized in 7th grade or 9th grade. So, whatever. So now I'm going to plug in the points here. X equals negative b, so that's going to be positive 96 plus or minus the square root of b squared, so negative 96 squared. That will become positive. Minus 4, a is 12, c is 144, divided by 2a, so 2 times 12. I'm pretty sure, so you see I'm going to say this. For this problem, there's like this magical set of numbers that you can choose that gets you a perfect round answer. I do this problem about 6 to 10 times a semester, just because that's typically how many times I go over this with my students. And every time I try and pick new numbers to try and find out what the magic number is. I've not found it yet. So then I Googled it. Or really, I just looked at my calculus textbook, and I was hoping it was round numbers. And this is supposed to be a round answer. So let's see if we get nice numbers here. It's going to be 96 plus or minus. I did this part. It's going to be plus or minus 48 divided by 24. I think we'll be good. I think so. Let's see. X equals 96 plus 48 divided by 24. 6 is one of our answers. Good so far. Then 96 minus 48 divided by 24. We get 2. Yay! We got nice numbers. Isn't that great? But these both of these can't be the maximum, right? So this is a perfect opportunity where we're going to use the first derivative test to prove our answer. You can use second derivative test to prove it, which would involve, again, taking the second derivative, finding the concavity. Is it concave up or concave down at x equals 2 and x equals 6? But I think that's more trouble than what it's worth. So we have our points 2 and 6. We're going to be plugging into the first derivative, which again was this equation right here. Now, I'm going to save ourselves some time. I mean, you can plug this in a calculator, obviously. If you plug in a number less than 2, like 0, you're going to get a positive. If you plug in a number like 3, between 2 and 6, you're going to get a negative. And if you plug in a number greater than 6, like 7, you're going to get a positive. I trust that you can do that, especially since we just spent the first half hour talking about this. So again, this is the first derivative. Now, think about this. Where's the max? Where's the min? If you said 2 is a max and 6 is a min, you are correct. Max at 2, min at 6. So which one do we care about? The question said we want to maximize volume, so we're looking at x equals 2. And we're going to be ignoring x equals 6. And in case you're wondering, the answer actually can't be 6 anyway. Why is that? Look at my box right here. I'm saying it's 12 inches by 12 inches. If x was equal to 6, think about this. I'm folding x equals 6 inches on both sides, right? Like, what would my width be? My width would be 12 minus 2 times 6, so 0. You can't have a width of 0, so that's actually impossible. It couldn't be 6 anyway. So the answer is definitely going to be x equals 2. By the way, if you're wondering, did you have to know that x couldn't be a solution? No, you didn't have to know it, but it's pretty cool, so I mentioned it. So now we have our max x. It's x equals 2. How do we find y? Well, we'd plug into the constraint equation. Oh, wait, there is no y in this equation, right? Yes. So the volume was, again, 12 minus 2x times 12 minus 2x times x. And the reason I'm writing this again is because what did the question ask? If I were to scroll up to the top, it says, I want to find what is the max volume, which involves plugging in x into the volume. This isn't always what the question's asking for. Sometimes it's asking for the dimensions. Sometimes it's going to ask, what is x? But in this case, I actually want to find the volume. So now I just need to plug in 2 into this equation. 12 minus 2 times 2 is 4 times another 12 minus 4 times x is 2. It's going to be 8 times 8, which is 64, times 2. Volume is 128. And the units, did I give units? Inches? Yeah. Inches, and since it's volume, inches cubed. That was a very fun problem. Any questions on that one? Okay. So again, this was the question from your quiz last Friday. I hope, well actually now I hope it does show up on the test because you all saw it. If you get it wrong in the test now, it's your fault. But I think more likely what you're going to see is this next example, which I definitely want to cover. And this is another optimization problem. This is question number 7 now, still optimization. I have, again, a cube, or at least a box, rectangular prism. But this time the top is not sealed off. Or, I mean, it's not empty. This is like a fully sealed box. Okay? Now I'm going to tell you some things about this box. Number 1, it has a square base. So what does that mean? Well, if I were to think of the dimensions for this box, normally it'd be length times width times height. You could say, length times width times height. But since it's a square base, the length and width are going to be equal. In other words, I'm saying x and x, both of them are the length and width. And then the height, I do need a new variable. I'll use y. So hopefully that made sense. Anyone have any questions on how I got this? Since it's a square base, length and width are the same. The height, I just need a new variable, so I called it y. Okay. The next thing I'm going to tell you is we need a volume of 12 feet cubed. We need a volume of 12 feet cubed. Here's the next part. This is where you're going to start hating me. The top and bottom cost $2 per square foot. Yes, this is a cost equation. This is the worst case scenario, so I want to talk about it so you're ready for tomorrow. And then I'm going to tell you all 4 sides. The 4 sides cost $3 per square foot. Okay? And finally, my question, what dimensions minimize the cost? What dimensions minimize the cost? Okay, I'll give you another 10 seconds to write that down, but start thinking. Start thinking, what's my objective? What's my constraint? Okay, I'm going to get started. So first, the objective equation is the thing we want to maximize or minimize. If you say volume, you're wrong, because I want to minimize the cost. So it's going to be a cost equation. Now, we don't have a cost equation, so I'm going to actually skip the objective equation for a second. Let's move to the constraint, because the constraint's actually much easier. So my constraint is typically whatever number they give me here. In this case, they told me the volume was 12 feet cubed. So volume is actually going to be the constraint. Volume is normally equal to a length times a width times a height. So since x times y is our length, width, and height, then the volume is going to equal x squared times y. It's x times y. X squared times y. So that's my constraint. And here's the thing you need to know about these problems. So this happens all the time. In this problem, there's volume and there's surface area, because we're talking about a 3D object. So for a 3D object, we have volume and surface area. These two are always going to be your objective and constraint. It's like one or the other. Like, constraint isn't always volume. Constraint could be surface area, but I mean, we talked about why volume's constraint, because it was the number, and I gave you the number. Okay, so this is it for 3D. It's volume and surface area. Always. They go hand in hand. For a 2D object, like if you ever see a fence problem, like a top-down view, anything like that, like a field, then in that case, instead of volume and surface area, it's area, and that goes along with perimeter. Perimeter. One is going to be the objective, the other is going to be the constraint. I don't think you're going to see any other examples other than these two. Okay, so since volume was the constraint, and we're talking about a 3D object for this one, it means that the cost should be the surface area. Okay, so let's talk about this. I'm going to draw C again down here because I need the room. So I'm going to scroll up for a second. I have how many sides on a rectangular prism? I have 6, right? I have the front, which I'll label blue. I have the side, which I'll label red. I have the top, which I'll label green. I'm assuming you all brought your colored pencils, right? Yeah, don't worry about it. But we also know that the blue, the front, is going to be also the same dimensions as the back, right? Like the back is blue. The right side's red, so the left side's red. The top is green, so the bottom is green. This is a symmetrical object, right? So what am I saying? It means that there's 2 blue sides, 2 red sides, and 2 green sides. So I'm going to remember that when I'm making my surface area equation. So now if I were to ask myself, what is the area of the blue? What's the area of the blue? I'm going to tell you, hopefully you see it, or at least you'll see it when I say it. It's x times y. The blue, the area is x times y. The length is x. We see the height is y. It's x times y. So I'm going to scroll down. Cost is equal to x times y for the blue. Again, there's 2 sides that have x times y because there's the front and the back. Okay? And now for cost, I need to multiply this whole thing by the cost. That's how you factor in cost. You just need to multiply the cost by the area. So what do we say the cost was? This is the sides, one of the 4 sides. So it's $3 per square foot. So just times 3. Any questions with that? So notice we still have 2 more to do. We have the left and right side, and then we have the top and the bottom. This is just the front and the back. So now plus, let's do the red next, the sides. So what's the area of my sides? Notice the base is x, the height is y. So that area is going to be xy as well. And again, since there's 2 sides, it's times 2. And also, this is the sides, so that cost was $3 per square foot. It's identical to the front and back for this specific example. Not all the time, but for this example where we have a square base. And then for the last example, or the last side's the top and the bottom in green here. So for that, if we think about what the area is, it's going to be x times x for the green. Everyone see that? X times x. So the green is going to be x squared. Again, there's a top and a bottom, so 2. And how much does the top and the bottom cost? We said $2 per square foot. So just times 2. There's our cost. Yes, we can simplify it. Let's just go ahead and do that right now. So cost equals, excuse me, 2xy times 3 is going to be 6xy plus another 6xy plus 4x squared. This will ultimately simplify to cost equals 12xy plus 4x squared. Now, I would love to find the derivative of cost right now and start finding the max and min, except we still have 2 unknown variables, remember? This is why we have the constraint equation. So we can solve for x or y, plug it in, and now we're down to 1 variable. So now I'm going to go back to my a constraint equation, which we said volume was x squared times y. Volume equals x squared times y. And we said that was equal to 12. The volume was equal to 12. So if I need to solve for x or y here, please, please, please solve for y. Y is going to equal 12 over x squared. If you solve for x, you're going to take a square root. You need the plus or minus. It's just a nightmare. Don't do it. Just choose y because it's not squared. Then we need to plug in y, the constraint, into our objective equation, y variable right there. So when we do that, we're now going to have cost equals 12 times x times y is 12 divided by x squared plus 4x squared. Let's go ahead and simplify this. So cost equals, the 12s can simplify, so 12 times 12 in the numerator is 144. One of the x's will cancel in my denominator, so we still have an x in the denominator, and then plus 4x squared. Now we can take the derivative of this. Let's go ahead and do that. So c prime derivative. You're already running into trouble if you have 144 over x, right? Because that's technically a quotient rule. Now, if you don't want to do a quotient rule, you don't have to, if you rewrite it as 144x to the negative first power, right? Whenever you write negative first power, you get to bring it back up to the numerator. So it's going to be, the derivative of this is negative 144 times x, now to the negative second power, plus derivative of 4x squared, that's going to be 8x, and now we set this equal to 0. Okay? Did I lose anyone yet? Am I going too fast for anyone? Okay, let me know if I'm ever going too fast. So now if we want to solve for x here, we're going to run into trouble again because the negative second power, I mean, it's just not easy to do. So for that reason, for solving for x, you actually want to put that x back in the denominator. I repeat, put it back in the denominator when you want to solve for it. Negative 144 over x squared plus 8x, that's going to equal 0. There's a couple ways we can solve for x now. I'm going to do the way that I think is most intuitive to you guys. I'm going to add 144 over x squared to both sides, like this. On the left, I still have 8x. On the right, I have 144 over x squared. Now I need to multiply both sides by x squared. So on the left, I'm going to have 8x cubed now, 8x cubed. And on the right, I just have 144. Then divide both sides by 8. X cubed equals 144 over 8, whatever that happens to be. And then I just need to take the cube root of both sides. So if you have a calculator on you right now, I encourage you to try typing this in because there's a decent chance you're going to need the cube root on your test. And in case you're wondering, I don't know where the cube root button on my scientific calculator is. Well, let me be honest with you for a second. I don't know where it is either on your calculator. But I do know this. If you just type 144, well, actually, sorry, parenthesis 144 divided by 8, close parenthesis, caret, raised to the 1 divided by 3 power, that's the same thing as a cube root. You're going to get x equals 2.62. Now, again, we do need to prove that is the minimum cost, right? Because we're finding minimum cost. I'm going to kind of speed through this real quick because, again, we already did this a bunch of times already today. But you'd plug in a point less than 2.62 into our first derivative. I'm going to scroll up for a second, actually, real quick. So we have two forms of the derivative, right? We have this one with the negative exponent, and we have this one with the x squared in the denominator. Which one should we plug into? So the answer to that question is a personal choice. I do not care. Whatever you think is easier, do it. They're both right. You should get the same answer as long as you're good at plugging into calculator. I would personally choose the bottom one, though. I would choose the bottom one personally. I think it's easier. So if you do that, I'm just going to tell you the result. If you plug in 1, you're going to get a negative number. If you plug in x equals 3, you're going to get a positive number. This is a minimum, min at x equals 2.62. Okay? Now, we're not done this problem yet because, again, what was the question? I'm going to scroll up. We wanted to find what dimensions minimize the cost. So we found one of our dimensions. It's x. How do we find y? We have that nice equation from the constraint that says y equals 12 over x squared. Remember that from the beginning? So y equals 12 divided by 2.62 squared. I'm going to plug this in now. 12 divided by 2.62 squared. And I'll get y equals 1.75 approximately. So there we go. There's my dimensions. I forget if it was feet, I think. Yeah, it was feet. So the dimensions are 2.62 feet by 2.62 feet by 1.75 feet. I ran out of room, but you get the point. And that's how you'd write it. Any questions on this one? Anyone still writing? Yeah, so I'd recommend looking over this example again, or if you have a study guide question that's similar to this one, really, this is the question I think is going to be showing up on your exam. I'm pretty darn sure of it. Okay. We're going to move on then to the next topic. We're finally on to exponential functions and derivatives. Yay, very fun. Number 8, I have the function y equals quantity 1 over e to the x minus 2x cubed. I do not mess around with you guys. We're starting off with the hard one, and I want to find y prime. So the first thing I would do if I were you, I wouldn't even find y prime. I would say, let's rewrite this. So this is going to be a chain rule. I know I'm going to have trouble with this 1 over e to the x, though. It's going to be a quotient rule. Unless I rewrite it as y equals quantity e to the negative x power, right? Whenever you raise it to a negative power, you're saying take the reciprocal. So now it's back in the numerator. E to the negative x minus 2x, that's cubed. Great. Now this is a much easier derivative to take. Now it is going to be chain rule, which is not fun. So if you're not good at chain rule, I definitely recommend looking this over on your own. But for now, I'm just going to quickly go through it. With chain rule, you deal with the outside rule first. So this cubed. This cube's going to go out in front. So 3 times the original quantity, e to the negative x minus 2x. That's then raised to the 3 minus 1 power, so squared. A lot of you forget that. Don't forget it. And then we're still not done. The chain rule says then multiply this by the derivative of the inside. So what's the derivative of e to the negative x? Remember, you take the derivative of your exponent, so the derivative of negative x is negative 1. So negative 1 e to the negative x. Keep the denominator the same. It's not negative 2x. This is not the power rule. This is the exponential rule. And the exponential rule says keep that exponent the same. Don't touch it. And then derivative of minus 2x, that's just minus 2. There's our derivative. We're done. Can you simplify it? I mean, not really. Honestly, this is about as simplified as you can get. Okay, and that's it for number 8. Any questions on that one? Anyone still writing? Good. Number 9. Number 9, I have y equals square root of x times e to the x squared plus 1 power. And again, I want to find the derivative. So again, the first thing I would do here, I'd rewrite the square root of x as x to the 1/2. Y equals x to the 1/2 power, e to the x squared plus 1. Now, I want all of you to take 5 seconds and think about what rule of derivatives is this. You don't have to shout it out loud. I don't want you to. Just think about it. What rule of derivatives is this? Now, there's a couple right answers, but if you said product rule, I'm happy. And if you didn't say product rule, I'm mad at you. So please notice this is product rule, because if you don't, you're going to not fail your test, like, let's be honest, but you're going to get this one wrong, like hands down. So why is the product rule? Because we have this times that, okay? So y prime, our derivative, remember, it's going to be f of x times g prime of x plus g of x times f prime of x. And the quotient rule is something different, obviously. I can write it down later, but in another problem. But this is the product rule, don't forget it. So f of x, that's our x to the 1/2 power. G prime of x, that's the derivative of e to the x squared plus 1. So I'm going to ask myself, what's the derivative of x squared plus 1, my exponent? It's going to be 2x times e to the x squared plus 1 power, and parenthesis. So that's the first one. Next, plus g of x, which is e to the x squared plus 1, times the derivative of x to the 1/2 power. That's going to be 1/2. This is a power rule, okay? 1/2 x to the 1/2 minus 1 power. So negative 1/2. Yes, it's very hard to remember all these rules, but I suppose the alternative is just getting the wrong answer and failing the test. So if you want to choose that, I encourage you to. For those of us who want to choose to take the hard path and actually learn this stuff, we're going to do great. And this is the final answer. Do you have to simplify this? I don't think so. I think this is fine. And I'm going to move on to the next question. Any questions on this one? So I did mention quotient rule. I'm just going to quick give you the equation for quotient rule. Quotient rule, it's y prime equals g of x times f prime of x minus f of x times g prime of x divided by g of x squared. G of x squared. And that's it for quotient rule. And yes, I recommend you have both memorized. Okay, with that, we're going to move on to number 10. It's a similar problem, but it's a new twist on an old classic. I want to find the equation of the tangent line, everyone's favorite question. Equation of the tangent line given f of x equals 5e to the 2x at x equals 0. So a lot of you are terrible at these questions, and it really amazes me because we've been doing it for so long. But if you don't know it, that's okay. I'll just make fun of you now, and then I don't have to make fun of you by the end of tonight. So we need two things. We need a slope, and we need a point. So for those of you who just blindly take the first derivative as your first step, yes, that's technically right, but I'm pretty sure you don't know what you're doing. You're just blindly taking the derivative. So remember, derivative is slope. We will be taking the derivative to find the slope. So what's the derivative of 5e to the 2x? Well, the 5 is just a coefficient. I can write it out in front. Times derivative of my exponent 2x, that's just 2. So 2e to the 2x, there's my derivative. This can simplify to 10e to the 2x. And now, I'm not going to keep this. This is wrong if I just keep this. And if you said equal to 0, you clearly don't understand what's going on here for this problem. We want to find the equation of the tangent line at x equals 0. So to find the slope at this point, plug in 0 for x. F prime of 0 equals 10 times e to the 0 power. What is e to the 0 power? For those of you who say 0, I don't know how you even passed algebra 2, but that's okay. E to the 0 power is actually just 1. 10 times 1, you're going to get 10. So 10 is our slope. 10 is m in that equation, y minus y1 equals m times x minus x1, point slope form, which I love so much. And now there's still one more thing we need to find, and that is the point. So a lot of times they actually give you the coordinate point, like they'll say 0, 4, for instance. It's not 4 in this example, but I'm just saying that if it was 4. So how do we find the y coordinate? Well, for this, I just need to plug in x into my original function. If you want to make a note of that, write it down. To find the point, plug it into the original function. So I'm going to say f of 0, plugging in 0. It's going to be 5e to the 2 times 0 power, so just 0. Again, what's e to the 0? That's right, you got it right this time, I hope. It's 5 times 1, so just 5. My y1 is 5. In other words, my coordinate point is 0, 5. I have coordinate point 0, 5. I have slope m equals 10. I'm now ready to plug into this equation. Y minus 5 equals 10 times the quantity x minus 0. I think you can keep it like this, but in case for some reason you can't, you're not allowed to, what you would do is y minus 5 equals distribute the 10 to both terms. So just 10x minus 0, so just 10x. So then you get y equals 10x plus 5. Again, I think you can keep this form up here we had originally, but this is what it is in just y equals form. Any questions on that one?
Could you scroll back up real quick?
Yep.
Thank you.
How high? This high?
Where the point slope form is.
Oh, so right here?
Yeah, thank you.
Yep. Any other
I have
questions?
a question.
Yeah.
Why did the first step, the f prime of x?
Yeah.
Why did you pull out the 5 and then do to it?
Yeah. So for that reason, I'm going to scroll up. Yeah. So the 5 is a coefficient. So I just take it along for the ride. And then the 2 came from the fact that the derivative of e to the 2x is 2. Does that make sense?
Yeah, thank you.
Yep. Any other questions?
Could you do product rule for that one?
That's a good question. I was wondering if someone would ask it. You can, but you shouldn't. It doesn't make... I'm going to say you can, but it doesn't make sense to. You're going to get a really weird answer. But that's because you don't do it because there's no x here. If there was an x here, yes, it's a product rule. Without the x, it's just a coefficient. Does that make sense?
Yeah.
Any other questions
Kind
on
of.
that? Or is that good? Okay,
I think that's good.
cool. Oh, and again, if you do have any questions, again, I'm sticking around after this, so don't worry about it. I mean, at this rate, we just finished question 10. There's still 10 more to go, and there's half an hour left in this review. We're probably going over. However, as I said before, I'm fine with going over a little bit. And honestly, the back half's going to be a little bit faster than the first half, so don't worry. So number 11. Number 11, we're going to be talking about exponential simplification. What does that mean? I want to simplify this following expression. Big quantity, and we're going to have a big fraction bar. First, I have x to the n plus 2 power times y to the negative n plus 5 power divided by x to the negative 2n times y to the 4n plus 3 power plus 3. And if you thought that was too easy, then okay, fair enough. I'm going to square this whole thing. And I want to simplify this. Most of you hate this problem. I'm okay with that. So here's what we're going to do. First, we need to keep the x's and the y's separately because they're different bases. Now, what I'm going to do is anything that has an x in the base, and since I have one in the numerator and one in the denominator, I'm going to rewrite it like this. We don't need the fraction bar anymore, by the way. It's going to be x to the n plus 2 power minus my denominator, so minus negative 2n. Yes, that will become positive in the next step. Then times y to the negative n plus 5 power minus 4n plus 3. So I'm just subtracting the thing in the denominator. Close parenthesis, this whole thing is squared. Now let's simplify this. So this is going to equal, my x is going to become n plus 2 plus 2n. So that's actually going to be 3n plus 2. I'm just going to write that real quick. 3n plus 2. And then for y, that's going to be what? Negative n plus 5 minus 4n minus 3. So I'll just write that in the next step. I'll simplify it. That whole thing squared. So then again, x 3n plus 2. Y is going to be negative 5n plus 2. Everyone see that? I hope I didn't make a mistake. This should be right. And then this whole thing squared. So now we're not done yet. The last thing we're going to say to ourselves is whenever you have like a power raised to another power, you want to multiply the power by 2. Now here's a question for you guys. This whole thing's squared. Where does the 2 go? The correct answer, the 2 goes multiply by this, and you multiply the 2 by that. That's how you deal with exponents. Both are multiplied by 2. So it's going to be x to the 2 times 3n plus 2 times y to the raised to the 2 times negative 5n plus 2 power. And yeah, let's just simplify this real quick. It's going to be x to the 6n plus 4, just distribute the 2, times y to the negative 10n plus 4. This is our final answer. This question came up on Tuesday, so I'm just going to repeat it now. When should x or y go in the denominator? Because that's actually a good question for simplification. First of all, the answer in general is, I'm going to say never. Even if you have negative exponents, that's fine, technically. This is fine if it's the answer. But when would I put it in the denominator? I would only put it in the denominator if both terms had a negative sign in it. So look at negative 10n plus 4. If that was negative 10n minus 4, then yes, you could put it in the denominator. But again, even if you leave it like in the numerator, it's still fine. It's right. In my opinion, you can't get points off for it. It's not wrong. Okay, any questions on what I just said? Okay, anyone still writing? Now let's move on to a slightly different problem. For number 12, I just want to solve for x. I have 60 divided by 2 plus e to the 0.5 x power, and that's equal to 15. Easy, just solve for x. So this, yeah, obviously it's not so easy, but I'm going to tell you the first thing you do is multiply both sides by your denominator to get that denominator out of the way. So when you do that, the left side's just 60. The right side's going to be 15 times the quantity, 2 plus e to the 0.5 x power. Now what I'm going to do, I'm going to divide both sides by 15 because I'm solving for x. I need to get x by itself. So 60 divided by 15 is just 4. 4 equals 2 plus e to the 0.5x. Then I'm going to subtract 2 from both sides. So now 2 equals e to the 0.5x. And now, how do I solve for x here? Well, I need to get rid of the base e. And the only way I can do that is by taking the natural log of both sides. Now, natural log and e cancel out, and so natural log of 2 on the left equals now just 0.5x. So if I just divide both sides by 0.5, we get natural log of 2 divided by 0.5, and this is fine as your final answer. You can plug it in as a decimal. I don't care. This is good. Any questions for this one?
So for this one, would the directions just be like solve for x?
Exactly. Yeah, did I write that?
Okay.
I think I missed that. Sorry. Solve for x. Yes. Any other questions? Okay, so that's going to do it for that topic. Next, we're going to move on to everyone's favorite, exponential growth and decay. Yay! So I hope you guys like writing paragraphs, because that's going to be the next 2 problems. The population of a town can be modeled by P of t equals 1000 e to the 0.2 t power. Okay, that's the initial question. Part A. What is the initial population? What is the initial population? Okay. So the first thing you need to know about these problems is that they're always going to be written in the form q equals q naught times e to the kt or negative kt power. And each of these variables mean something specific. Q is our final amount. Q naught is the initial amount, which is going to be our answer. K is the growth or decay constant, depending on which problem we're looking at. In this case, it'd be a growth constant. And T is obviously time. So as you can see here, 1000, which is in the position of Q naught, is my initial. So my initial population, 1000 people. And we're done. No math involved. Just understanding the equation. Okay, let's say part B. Part B, I want to know what is the rate of growth of this population at t equals 0. Rate of growth at t equals 0. So if you remember, a rate of growth, a rate is a change in something over change in time, which means derivative in calculus. In other words, I want to take the derivative. If P of t is 1000 e to the 0.2 t power, then I need to take the derivative of this. P prime of t is going to be 1000, because that's just the coefficient, right? Times the derivative of 0.2 t, which is just 0.2, times e to the 0.2 t power. Hopefully you remember your derivatives of exponential functions. And again, this is not the answer just yet. I want to find the growth rate at t equals 0. So last step, plug in 0 for t. You're going to get P prime of 0 equals 1000 times 0.2 times e to the 0.2 times 0 power. Question, what's e to the 0 power? Hopefully you said 1, because we already talked about this earlier tonight. So it's 1000 times 0.2 times just 1. 0.2 times 1000 is actually just going to be 200. So the units for that, people per... did I even give a unit of time? I don't even think I did. I'm going to say people per year. I should have said year. Sorry. But yeah, that's going to be our growth rate. Any questions on that one? Again, rate of growth, take the derivative.
Could you use, I'm so confused on like why you keep 1000. Like, could you do the product rule here?
You don't want to do the okay, let's actually talk about the product rule here, because I just want to show you guys what happens if, let's say you miss it. Let's say you try the product rule, you don't know any better, and that's fine, because it's going to work out. It's just going to be longer to get there. So you're going to say this. P prime equals, I just need to write the original, 1000 e to the 0.2 t. This was the original. So f of x is 1000. G prime of x is 0.2 e to the 0.2 t. This is exactly what we said the derivative was, right? So then finishing out the product rule, you're going to add e to the 0.2 t, which is g of x, times what's the derivative of 1000? It's 0. This whole thing goes away, and that's why I was saying it didn't matter. Now, why did it matter when we had the x there? Because when we have x here, what's the derivative of 1000x? That's 1000. That's not 0. It does matter. Does that make sense to you now?
Yeah.
Great. It was a good question because a lot of times we just take it for granted. Okay, but this is going to be our derivative. This is our rate of change, 200 people per year. And then question part C, how long for population to double? So this is everyone's favorite question because this is really where the hard part of growth and decay comes. Now, luckily I gave us k already. It was 0.2, in case you didn't notice. So what I'm going to say for this one is q equals q naught e to the kt, right? This is our equation. I know my initial is 1000, and if I want my population to double, notice that's just going to be 2000. Now that's the other thing. I don't even need to tell you what the initial population was. I was nice. If I wanted to, I could just leave the information out, and then what would you do? Well, besides cry, a lot of you would cry, but for those of you who don't cry, you would say, okay, well the initial is q naught, right? Well, if it doubles, then it's double q naught, whatever q naught is. Q naught cancels. You're going to see the exact same thing here. 2000 cancels with 1000 to leave us with 2 on the left side. That's what happens every time with these problems. You get q naught to cancel out. I need to finish writing this. E to the 0.2t power. Okay. So now 2 equals e to the 0.2t power. Everyone still with me? So again, I need to solve for t. This is when the time double, or when the population doubles. Again, we're going to take the natural log of both sides. So natural log of 2 on the left. On the right, we just have 0.2t. I just need to divide both sides by 0.2, like this. And we'll get a time of, plugging in my calculator. Hopefully all of you know how to plug in natural log in your calculator. You're going to get a time of 3.47, we'll say, years. And that's the answer to, what is this, number 14? Yeah. Any questions? Okay. Moving on to number 15. Number 15, we have the following. I'm just going to kind of condense the information. I'm going to say half-life is 612 years. Very fun number. And I want to know how long until 20% remains. So again, half-life, oh, that's supposed to be the word is. That's horrible. Sorry. Half-life is 612 years. Better. Now, if you remember with these problems, half-life is saying how long does it take for half the matter to decay, go away. This is going to be exponential decay, and now I need to change something from what I said back on, what was it, Tuesday? Yeah. I'm going to say write it as e to the negative kt. Why? Because I'm pretty sure that this problem is going to be 2 parts when you see it on your exam. The first question is going to ask you to find k. And if you say k is a negative number, which normally it is for exponential decay, they want you to use this equation. I'm telling you right now, for decay, they want you to have this negative sign in the problem. In other words, they want k to be positive. K needs to be positive. That's what your professors are looking for on the test, okay? I'm sorry, I don't make the rules. I think negative k is fine, but they don't like that. So here we go. I'm going to say q equals q naught e to the k negative kt. This problem is 2 parts. The first part is I'm going to use this information, half-life is 612 years, to find k. That's what we always do with these problems. We use the first sentence or first piece of information to find k. We then use k to find the second part, how long until 20% remains. So let's do the first part first. Half-life is 612 years. So what's the final? Like, I noticed I had no idea how much I started with. Well, if I'm saying half, then it's going to be half whatever the initial is. Half of q naught equals the initial, which is just q naught, e to the negative kt. So I repeat, q naught is my initial. My final is whatever half of the initial is. Again, q naught is just going to cancel. And the other nice thing about this problem is I know t. I told you the half-life is 612 years. Great. So we're saying 1/2 equals e to the negative 612k power. And again, if I want to solve for k, I need to get k by itself. I need to take the natural log of both sides. Natural log of 1/2 equals negative 612k. Final step, divide both sides by negative 612. Negative 612. I'm going to plug this in a calculator real quick. Natural log of 1/2 divided by negative 612. I'm going to get k equals 0.0011325. It's a lot of decimal places. I recommend you write all of them down on your test. Why? Because if you don't, there's potential you get a rounding error for this problem. The final answer, we're going to round to 2 decimal places, but if you round this to even 0.113, you're not getting enough decimal places. There's a chance you can get a rounding answer and points off. I'm not joking when I say that. Other thing I want to mention, this is k. This is my value for k. If we didn't use that e to the negative kt equation, we just used positive kt, then we'd get negative 0.0011325. Luckily, the math doesn't matter. It's just a number. Everything else is going to stay the same for this problem. So then finally, I want to know how long until 20% remains. So a lot of you are going to not like this part because you're trying to figure out, is it 20% or is it 80%, because it's like 1 minus 0.2. I'm going to tell you, whenever you come across this question, there's like a couple ways you can approach it, but at the end of the day, my question to you is, what's the final amount? How much is left? Reading this question, how long until 20% remains? It sounds like 20% is left. The final is 0.2, not 0.8. Does anyone have questions on that? Because I know this is a confusing topic. In case you're wondering, what would the question be where it was 0.8? In other words, I'm saying 1 minus 0.2, which is 0.8. That would be if I asked how long until 20% decayed. 20% went away. It's 20% less. That would be 1 minus 0.2. Then it would be 0.8. Does that make sense? Okay. So just finishing up this problem then, we're saying that q equals q naught e to the negative kt. I like to rewrite it every time because it's helpful. So the final, again, is 0.2 q naught. It's 20% of my final. Equals whatever my initial was. Again, these will cancel. E to the negative 0.0011325. That's what k was. Times t. And now I just need to solve for t. 0.2 equals e to the whatever 0.0011325 t. Take the natural log of both sides, divide by negative 0.0011325. It's just the algebra. We did this already. That's equal to t. I'm going to plug this into my calculator. So natural log of 0.2 divided by that answer is, wow, 1,421 years. Very cool. Okay, any questions on that one?
So you would put the negative back. You would have a negative k because it's decaying.
Yes. So remember,
Even though your k was positive.
Yes, my k was positive, but it was only positive because I included this in the initial equation. And when do you include that negative sign? The answer is this a decay problem or is this a growth problem? The last problem, the population was growing. We didn't have the negative. This one, half-life, anything that's, decaying, going down, that's when you include the negative. Does that make sense?
Yes, thank you.
Yep, great. Now, luckily for the last, 5 problems here, these are going to go pretty quick. I cannot believe this. I ran out of room. That's never happened before. Let me open up a new sheet of paper. Congratulations, we did it. Got to, this is what, 15 pages, I think, of blank paper? Amazing. Okay, so here's the next one, number 16. For the rest of them, I just want to find the derivative. For the rest of the problems tonight, I just want to find the derivative. Easy. And here we have y equals natural log of x. This is the easiest one in the book. Hopefully you know this already. The derivative is just 1 over x. We're done. I would just know that because it's so common. Number 17, we have y equals the natural log of 3x minus 5. So whenever you get these more complicated ones, my recommendation to you is know this rule. A natural log derivative is the derivative of the inside divided by the original. So the derivative of 3x minus 5 is just 3. divided by my original 3x minus 5. I'm going to tell you, do not put the natural log. There's no natural log in the derivative of these problems, which is kind of funny. It actually makes our lives a little bit easier. And that's the derivative for number 17. For number 18, we have y equals the natural log of quantity x squared plus 4x minus 6. Again, y prime is, so I take the derivative of x squared plus 4x minus 6. That derivative would be 2x plus 4 in the numerator. In the denominator, the original x squared plus 4x minus 6. Easy. Hopefully you're starting to get the hang of this. Okay, now let's start talking about the hard problems. These were all easy. We have 2 problems left in the night. We're probably going to get finished by, what, 7? I'm going to guess 7:35, 7:40, we're going to be done, which is pretty good on time. I'm happy. So for number 19, this is a hard one. Y equals the natural log of quantity 2x minus 4 squared times x plus 10. You notice this got significantly harder real quick. So for y prime, a lot of you are going to say, oh, well, this is a product rule. And I'm glad you recognize that, but this is the one time where you don't want to do product rule. Why? Because we have properties of logarithms that is going to make this problem a lot easier. So y equals, what are the properties of logarithms? Well, in this case, we're multiplying 2 products together, which means it's going to be addition in the logarithms. What do I mean by that? It's natural log of 2x minus 4 squared plus the natural log of x plus 10. Everyone remember that? Very crucial that you remember this property. If you don't, it's going to really mess with you. And if it was division, it would be minus. Don't forget that. And then there's one more property of logarithms we need to remember, and that is this squared right here. So whenever we have squared in a logarithm, it's not a power rule. This is its own property of logarithms. You pull the 2 out in front, and then the exponent's just gone. If it was 3, it's not 3 minus 1. It's just gone. So y equals 2 natural log of 2x minus 4 plus the natural log of x plus 10. This is as much as it can be simplified. And now I'm ready to take the derivative. So we're like halfway done this problem. Actually, more than halfway. So for this derivative, what do we do with this 2? Well, this 2 is just a coefficient, so we're just going to take it along for the ride. So 2 times derivative of 2x minus 4 is a 2 in the numerator divided by 2x minus 4. There we go. Then plus derivative of x plus 10 is just 1 divided by my original x plus 10. This is our final answer. I mean, we can combine this 2 and this 2 for a 4 in the numerator, but this is fine. I'm okay with this. And I think your professor would be as well. Any questions on this one? Okay. And now for the final question of the night. I mean, we're going to end with the final boss, honestly. It's logarithmic differentiation. I don't know whether or not this will show up on your exam tomorrow. I'm like 50-50 on whether it does or not, so we're going to talk about it. I hope it doesn't because it's really hard. But let's talk about it. Logarithmic differentiation. This is just a beast. So let's say I have the problem y equals numerator x cubed, denominator square root of 2x minus 5 times the quantity negative x minus 1. Just like this. So I've got good news. There's no natural log here. We don't need logarithms. Actually, it's kind of nice, right? So if I were to take the derivative of this, remember it'd be quotient rule, right? I've got a division bar here. And I look in the denominator, and it kind of looks like a mess. I mean, I'm going to have a product rule here. The 2x minus 5 is also going to be a chain rule on top of it. This is just not a fun problem, and it's for this reason. And we mentioned this before, I think, maybe. Whenever you have product rule, whenever you have product rule and quotient rule, in the same problem, you're going to use logarithmic differentiation. Logarithmic differentiation. So what on earth does that mean? It's funny. The first step of logarithmic differentiation is make the problem harder. You're actually going to take the natural log of both sides. So the natural log of y equals the natural log of this whole thing. X cubed in your numerator. The denominator, I'm going to rewrite square root of 2x minus 5 as 2x minus 5 to the 1/2 power, right? Like that's just, we all agree with that. And then times the quantity negative x minus 1, close parenthesis. Now, why do we do this? This is harder, right? Well, now we can use our properties of logarithms. So before I even take the derivative, we're a long way before we even take this derivative. I'm going to rewrite this. My numerator is going to be the natural log of x cubed, and that's positive because it's in the numerator. And if I wanted to, I could even take this 3 out front, right? I can say 3 natural log of x. If you want to write that in 2 steps, that's fine. I encourage you to. But if you see it in 1 step, you know, I don't blame you for doing this in 1 step. And then all the stuff in the denominator will be minus. So minus natural log of 2x minus 5 to the 1/2 power. And again, that 1/2 can be rewritten out in front like so. 1/2 natural log of 2x minus 5. And then the last one, negative x minus 1. Again, that's going to be a minus natural log of negative x minus 1. That cannot be simplified. There's no power that we need to deal with. The left side is still natural log of y. Okay, is everyone with me so far? Did I lose anyone?
How come it would be minus ln instead of adding because you're multiplying them together?
Yes, because it's even though we're multiplying them together, it's still in the denominator.
Okay.
Does that make sense?
Yeah.
Great. So now the next thing, we're going to take the derivative. So let's start off with the left side. What's the derivative of y? What's the derivative of y? It's not just 1. It's implicit differentiation, which means derivative of y, I'm going to say 1 times dy dx. Or if you want to, you can also write y prime. I don't care what you write. Just it needs to be y prime or dy dx. I'm going to use dy dx because I like dy dx. Divided by, remember, with any natural log, it's derivative of the thing divided by the original. So dy dx divided by y. And dy dx is the thing we're solving for. I'm asking to find the derivative. So eventually I'm going to have to get that y in the denominator to the other side. But first, on the right side, let's deal with that. So 3 times natural log of x. Again, 3 is just a coefficient. Derivative of natural log of x is 1 over x. And then minus 1/2, which is also a coefficient, times derivative of 2x minus 5 is 2, divided by my original 2x minus 5, just like that. And then finally minus derivative of negative x minus 1 is negative 1 over negative x minus 1. And if you wanted to even see this negative and this negative 1 here, if you want to, you can even combine them to make it a positive. I might do that in the next step just because I don't want to confuse anyone here. Okay, and now the last thing we're going to do, multiply both sides by y. So when we do that, I'm going to get dy dx on the left. On the right, 3 times 1 over x is just 3 over x. Also, I need a huge parenthesis bar here. So 3 over x minus this 2 cancels with that 2, leaving us with 1 over 2x minus 5 there. And then finally, as I said earlier, these 2 minus signs cancel out. It's going to be plus 1 over negative x minus 1, close parenthesis times y. Now, I would love to say this is the final answer, but it's not. And that is because the last thing we need to do with this problem, notice we did not have a y in our initial problem, right? Our initial problem way back up here, this did not have a y in it. So what we need to do is I actually need to plug in for y. I need to say y is x cubed over square root of 2x minus 5 times negative x minus 1. Now, obviously, I ran out of room here. Hopefully, you didn't on your paper. But the other thing you can do, is you can rewrite y. Y equals x cubed divided by square root of 2x minus 5 times quantity negative x minus 1. And then you can just draw an arrow right there pointing to the y you drew in your derivative, just like I have here, and you'll get full credit for that as well. My recommendation, if you have room, just put the whole thing in. It's easier. And do not distribute. Do not distribute the y. Do not distribute this. This is perfectly good as your final answer, even though it's just a beast. Okay, this is the last problem of tonight, so any questions on that one? Don't leave quite just yet. I have a couple announcements at the end. But any questions? I will be sticking around for questions at the end too. Okay, so thank you all for coming today.